Today, we're going on a bit of a cosmic detective mission. We're going to look deep into the heart of a galaxy to uncover a secret structure, something hidden that tells us a ton, not just about that galaxy, but about our own home, the Milky Way. Our subject is the spiral galaxy Messier 98, and trust me, it has quite a story to tell.
So our whole investigation really boils down to this one question. What actually happens when a galaxy buckles? I know, it sounds pretty dramatic, right? But as you're about to see, what comes out of it is one of the most surprising and frankly beautiful shapes you can find in the entire universe.
All right, to find our answer, we've got to travel a long way, like 44 million light years away, out to the Coma Berenices constellation. And there it is, our prime suspect, the galaxy Messier 98, or M98 for short. Think of this galaxy as our cosmic Rosetta Stone. It's going to help us decode some really big secrets about how galaxies are built. Okay, so first things first in any investigation, right? Look, we're going to start by just taking a peek at M98's core and regular visible light. And almost immediately, we hit a snag. There's a bit of a mystery here.
Now, the key to this whole thing is our point of view. It's kind of special. We're seeing M98 almost perfectly edge on. Now, that's a bummer in one way, because it hides those gorgeous spiral arms, but it also gives us this amazing three-dimensional look at its flat disk and that central bulge. But look at that bulge. Something about it just feels off. It's really hard to make out what's actually happening in there.
And here's why it's so tricky. See that reddish streak running right through the middle? That's a super thick veil of cosmic dust, and it's totally blocking our view of the core's real shape. So, the big question is, how in the world do we see what's hiding behind that dusty curtain?
Well, we do it by changing the way we look. Simple as that. We're going to switch from the light we can see with our eyes to a type of light that can punch right through all that dust and show us what's really going on. And boom! Here's the solution. On the left, that's the view we had before, all dusty and obscured invisible light. But on the right, that's what we see in infrared light. The dust just evaporates, and it reveals the secret that M98 has been hiding. It's not a sphere, it's not some fuzzy blob, no way. It's something much, much weirder. It's an X. A giant glowing X is literally stamped right onto the galaxy's center. And let me be clear, this isn't some glitch or a smudge on the lens. This is the real, actual structure of the galaxy's core. Which leads to the obvious question, how on Earth does a galaxy end up with a giant X in its middle? Okay, get ready, because the answer is super cool. It all comes down to a really fascinating bit of galactic physics. It's a theory that connects this X shape to something astronomers call a peanut, which itself comes from something called a bar. I know, it sounds like we're at a snack counter, but stick with me. Let's break this down. Okay, step 1. You need what's called a galactic bar. It's a huge, long structure made of stars right in the middle of many spiral galaxies. I like to think of it as this massive river of stars, all flowing through the center and rotating together like a solid object. This is where it all begins. So you have this bar, right? And it's spinning along in the flat plane of the galaxy. But here's the thing, it's not totally stable. It starts to get a little wobbly, what scientists call a buckling instability. Basically, it starts to flex and flop, up and down, out of the main disk. And over millions and millions of years, as all those stars follow this up and down path, they trace out a 3D shape. Now, usually that shape looks kind of like a peanut still in its shell. But in really dramatic cases, like our buddy M98, the very edges of that up and down motion create this incredible, distinct X shape we're seeing. This whole connection is so important that researchers gave it, and I am not kidding, an absolutely fantastic name. Dr. Michael Merrifield called it the Snickers hypothesis. The big idea was, is there a peanut in every bar? Get it? And you know what? Their research proved it's basically true. M98 is just one of the most spectacular examples we've ever found. All right, so we've cracked the case of the strange shape. Awesome. But that's not the whole story. What's actually powering all the activity we see in M98's core? To figure that out, we've got to switch our vision again, this time to a whole different kind of light. We need X-ray eyes. When it comes to what's powering the center of a galaxy, there are usually two main suspects. Suspect number 1, a monster supermassive black hole, what we call an active galactic nucleus, or AGN. Suspect number 2, a stellar nursery, just an absolutely furious burst of new stars being born. So for M98, which one is it? The monster or the nursery?
Well, the X-ray evidence is pretty much the smoking gun. Clue number 1, the core just isn't bright enough in X-rays to be a full-blown AGN. Clue 2, the really high-energy, hard X-rays, they're not coming from a single tiny point like you'd expect from a black hole. They're all spread out. And clue number 3, the lower-energy soft X-rays show the classic signature of superhot gas, the kind of gas that gets heated up by supernovae, you know, the massive explosions when young giant stars die. All the evidence is pointing in one very clear direction.
So the conclusion is clear. The engine driving M98's core isn't one single central monster. Nope. It's the combined energy of a massive flurry of stars being born and stars dying. It is a true stellar powerhouse.
Okay, this has been a super fascinating deep dive into one galaxy, right? But the real payoff, the reason this matters so much, comes when we turn all this knowledge back around and look at our own home.
Because you see, studying Messier 98 isn't just about being curious about some faraway galaxy. It's actually like looking in a mirror. M98 is giving us this incredible outside view of a galaxy that is built a whole lot like our very own Milky Way. And this is why it's so important. We're pretty sure our own galaxy, the Milky Way, has a bar. And we have lots of evidence that our central bulge is also one of those peanut-shaped ones. But the problem is, we're stuck inside it. We can't just fly outside and take a picture. It's like trying to see the shape of your own house from the living room. It's impossible. So M98, sitting there perfectly edge-on for us, gives us this perfect, clear view of what our own galaxy's core probably looks like in 3D. It's like finding our family portrait taken from 44 million light years away. It just goes to show you the power of perspective, doesn't it? From infrared light that cuts through dust to high-energy X-rays that reveal cosmic engines. Every time we find a new way to look at the universe, it reveals another one of its secrets. Which kind of leaves you with one final thought, right? What other amazing cosmic secrets are just sitting out there waiting for us to finally look with the right kind of eyes?